follows right into your other notes packet from last week. If you look, the other notes packet ends on page 7. This one starts on page 8, okay? So it just follows right up. You could staple them together if you want. I honestly would maybe recommend that, adding them together. But for this first algebra problem, remember we'll do an algebra problem every day because we need to really get better at our algebra skills. Pause real quick. Chromebooks should be closed. Okay. On this first one.
Stop digging your butt.
Focus, boys. What should I do on the left-hand side?
Multiply everything
Plus,
Yeah, distribute. Do we all remember that word distribute? We'll talk more about it this week. But distribute that -4. So -4 times 2.5 is 10. And -4 times 8.7 is -34.8. Don't make me regret that, Isaac and Caden.
yeah, can I use it this time?
Use what?
The chair.
You were in it yesterday or last week. On the right-hand side, what should I do with this 6? It looks a little weird. Don't leave it alone. Distribute. But you're distributing it like almost reverse. It's just in a different order. It's just going to be moved into the other set of parentheses. So 6 times 1.4 is 8.4. And 6 times 9.2 is 55.2. So here's what we get. -10x minus 34.8 equal to, Jordan, equal to 8.4 minus 55.2x. Jordan, focus. Okay, which way, to the left or to the right, should I move my x's? What do we think? I agree with the left. Why to the left?
Because it'll be positive.
It'll make it positive. So let's add 52.5x to each side.
I think I'm wrong.
If we add that, -10 plus 55.2 is 45.2x on the left. And if I moved all my x's to the left, which way should I move my numbers?
To the right.
To the right. So I'm going to add 34.8 to both sides. The noises are so unnecessary. You get 43.2. All of these were a calculator problem. Don't even deal with the decimals. Put into your calculator. Same thing for this one. X is equal to 43.2 divided by what?
43.2.
No.
Oh.
45.2. Yeah. We divide both sides by 45.2.
It would be 108 over 113.
I agree, yes. The fraction your calculator gives you is 108 over 113.
The estimate would be 0.95.
And like Jordan said, this is an estimate. So if it asks you to solve for x, do not give it an estimate. Give it the exact answer, the fraction. Your calculator has the capabilities of jumping back and forth between the two. So if you need help with that, let me know. But give it as an exact answer, not as a rounded decimal. Questions on that one? That's algebra. The rest of our warm-up is geometry stuff we talked about last week. So last week we talked about conditional statements. What 2 words does a conditional statement use?
If only.
If and then. And a biconditional, Charlie, uses if and only if. Okay. So this first one says make a conjecture, meaning make an educated guess about the product. What is product? What
The end goal.
addition, subtraction, multiplication, or division?
Multiplication.
Okay. So we're multiplying an odd and an even number, and we're making a conjecture about the result. So anyone, give me an odd number.
47.
47. Okay, give me a small even number.
6.
Maybe 2. What's 47 times 2? Yeah, you do. 94?
94, yes.
94? Okay, give me another odd number, maybe smaller. Odd.
9.
Odd, 9. Give me an even.
17.
Even.
What's 19?
Even number, 6. Okay, 9 times 6?
6, 7.
54. Let's do 2 more examples so we can get a good idea. Give me an odd number.
17.
17. Give me an even number.
4.
6.
4. 17 times 4?
92.
No.
How do you do it?
68.
I was close.
Let's do one more. Reagan. 30. 3 for our odd number. Give me an even number.
8.
What, Reagan? 4. I like the small numbers. 3 times 4 is?
12.
12. Okay. Now what I'm doing is making a conjecture, a statement about these 4 numbers. They're all even. So my conjecture is the product of an odd and even integer is even. A lot of us on our self-checks had this part. We had the examples, but we actually forgot to write the conjecture. We didn't write the sentence of what pattern we found here. So if you lost points on this problem or one similar to it, that's probably why. But also on that self-check, I made notes for every problem that you lost, so you can see.
Was that one?
It was on Schoology.
Oh, I already took mine.
You did. Yeah, you're done.
Did I do better?
Wait, you retook it?
Yeah.
Oh, then I'll have to regrade.
Okay.
Okay. But questions on this one, making a conjecture. Okay, next one is doing a counter example. An example that is not true for this statement. It says the product of 2 positive integers is greater than either integer. When I talked about counter examples, I said there's like 3 sets of numbers or numbers that we probably want to take into account and maybe look at. They were negative numbers, zeros, and 1. Which of those, negative, 0, or 1, is a positive integer that I could use here? 1. So I'm looking at my 3 special cases. Again, your negative, your 0, and your 1. These are the types of numbers I would look at for counter examples.
Don't put white powder on my desk.
But none of those are positive. Jordan, focus. None of those are positive besides 1. So let's look at 1. Someone give me another integer that's positive. 17. What's 1 times 17? 17. Is 17 greater than 17?
No.
No. So therefore, it's a counter example. It's not greater than either integer. Let's do one more for good measure. What's 1 times 5? 5. Is 5 greater than 5? No. So that's also a counter example. Jordan, no thanks. And in general, if 1 is one of the integers, then we have a counter example. Oh, I also have more good news that you guys will really like.
Really?
Yeah, we will not be writing any more vocab cards.
For the rest of the year?
For the rest of the year, and instead of like the 10 minutes of writing vocab cards, we're going to play Quizlet Live for 10 minutes.
I like that.
Does that sound better?
Why can't
I agree. I agree. So starting like on Wednesday, you're going to come in, we'll do our game, and then we're going to jump right into vocab for the day. Quizlet Live. So make sure your Chromebook is charged.
Uh-oh.
Okay.
We should just do it now.
No. Focus, Kaden, turn around. So, last week, we did inductive reasoning. We went from small examples or observations or experiments to coming up with a pattern and making a conjecture for the general case. Today, Jordan, you actually are going to come up here for the rest of the hour.
Okay, I'm sorry. I'll be quiet.
No, you can do what I asked.
Please. I promise you.
It's not an option, Jordan, and I don't trust whatever you're doing behind your backpack either. So,
I was sleeping.
okay, I want you to come up here. Charlie. Yes. So, last week we went from small cases to big cases. Now we're going to kind of do the opposite. We're going to look at the larger case and the larger rules and logic of math, and we're going to narrow it down almost to a smaller case. So, we call that process deductive reasoning. So, deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. If you ever heard that geometry writes proofs, That's where this comes in. Deductive reasoning we are going to do some proofs. They're not terrible, but that's where our deductive reasoning comes in.
Hey,
Jordan,
I can't see.
go. Not at snail speed, please. Okay. So today we're going to learn about two different laws that relate to our conditional statements. The first one is the law of detachment. And it says that if the hypothesis of a true statement is true, then the conclusion is also true. What this means is you'll be given an if P, then Q statement. And then you'll also be told a specific example for which P is true. So you'll do some example of P is true. This is what you're given. You will then conclude, well, if my hypothesis is true, which it is, then my conclusion happens. So my conclusion, or what I actually conclude, is just Q, that Q is true. So let's do like a mental example of this. If it's raining, then I will bring my umbrella. And then I told you it's raining. What can you conclude? I'm going to bring my umbrella. You just did the law of detachment. That's it. If you have your hypothesis and it's true, you follow your arrows through to the conclusion. Another way you can kind of think about this, Jordan, is if you have P implies Q and P, you're almost like plugging P into your arrows and you're reaching your conclusion. You can kind of think of it as plugging into your conditional statement. So, let's do some examples. For anything where you're asked, what can you conclude from the following? I want you to label each different statement. So if you want colors, go grab some colored pencils or markers, or you could just label it P, Q, and whatever else. Okay? So it says, if X has the value of 7, let's call X having the value of 7 P for now. P. Then 2X minus 3 has a value of 1. Is this piece the same as the yellow piece or something new? Something new. So let's call it something new. Let's call it Q. And let's highlight it a different color. So that first piece gives us our conditional statement, P implies Q. Then we have the second piece. It says the value of X is 7. Is that a version of P or of Q? Of P. So let's label it as P. And then look at what I have. I have P implies Q. I'm told that P is true. What can I conclude? What do we think? Huh? Yeah, we conclude that Q is true. So the orange is true. So that 2X minus 3 has a value of 1. And that's it. We're essentially plugging our hypothesis back in and following our arrow to the conclusion. I'm going to skip this one for now. You'll see why in a second. Let's go to the third one. It says, if two segments have the same measure. I'm going to pause right there. I'm going to take that first piece and I'm going to call it P. Then they are congruent. Is they are congruent something different than this yellow piece or the same? It's different. So I'm going to label it a different color. And I'm going to call it Q. And then it says, we determined that AB is equal to XY. Does this piece, AB equals XY, does that deal with segments having the same measure or segments being congruent? What do we think? Raise your hand for same measure.
Yikes.
Raise your hand for congruent.
Crickets.
Does this have a congruence symbol? No. So it's for yellow. It's same measure. Remember, when we write the segments down without the segment symbol on top, we're talking about their length. So this right here is a specific example of two segments having the same measure. So we plug this in. A and B have the same measure. So then we conclude what? A and B are congruent. Perfect. So our conclusion is AB congruent to XY. Huh? At the end of the lesson.
Just Cruz, if you, Keith's okay, and if he's gonna throw something at me, you should at least hit me.
You should at least just like not do that.
I would agree.
Stop throwing
Say
things.
like, don't throw at me.
Okay. Focus. So again, we have a specific example of our hypothesis. We plug it in and we get a specific case for our conclusion. That's it. We do it again. This one says if an angle is a right angle, so that's going to be P. An angle is a right angle. Then it measures 90 degrees. Is this 90 degrees something new or the same as the yellow thing?
New.
In our brain, it should be the same, but really it's a new statement. In our brain, we know right angles go with 90 degrees, but on paper, they are different. And then it says ABC is a right angle. Is that yellow or orange? It's yellow. It's P. So again, what can we conclude about angle ABC? It's 90 degrees, exactly. The measure of angle ABC is 90 degrees. That's what we conclude. ABC is a right angle, so therefore it must be 90 degrees. Sometimes, though, they will try to trick you. Let's look at this one. It says, if Miss Cruz goes to the movies, let's call that P, Miss Cruz going to the movies. Then she will get popcorn. That's a new statement. Let's call it Q. And then it says, Miss Cruz got popcorn. Does this go with P or with Q? Q. So here, is there something that we could plug in and follow our arrow through? Can we go backwards? Does this arrow, this relationship go backwards? No, that arrow's pointed one way. So this Q tells me really nothing. Can I conclude that I went to the movies? No, I could have ate popcorn on my couch. Okay, so here, there's no conclusion. Because they tried to trick you. They gave you the conclusion example versus the hypothesis example. Reagan, what's up? Was that? Okay.
Can we go to the bathroom?
Yes, quickly. Questions on the law of detachment. You plug your hypothesis in, you follow it through to the conclusion. Put those away. Will. Okay, this next one is one of my favorite laws ever. And we're all going to say it together because it's kind of a tricky name. It's the law of syllogism. So, yeah, say syllogism for me. Syllogism. Okay. It says, if the first two connected conditional statements are true, we'll talk about what connected conditionals are in a second. But if they are true, then the third is also true. Here's what you will be given for the law of syllogism. You'll have if P, then Q. And you'll have if Q, then something else. Call it R. The law of syllogism, what I like to say is we cut out the middleman. This Q here is connecting our conditional statements. It's the conclusion of one and it's the hypothesis of another. And when this happens, when your middleman is the same, he goes away. We can cancel him out. And what we conclude is if P, then R. So if you want to write next to the law of syllogism, cut out the middleman. That's the way I like to remember it. We cut out the unnecessary information that links back up to itself anyways. So this one's really crucial that we label P, Q, and R. We now have 3 statements, 3 colors we're going to use. So, let's do an example. If the sun is shining, so the sun is shining will be P. Then it is a great day. Is that something new or is it the same thing as the sun shining? It's new, so let's call it Q. If it is a great day, is this part P or Q? Yellow or orange? Q, so orange. Then I will have a picnic. That is something completely new. Let's call that R. Okay. First question here is, do we have a middleman? Yeah, who is it? It's Q. So, Q goes away. We're canceling Q. And we get if P, so if the sun is shining, then what happens? We ignore the great day. What happens at the very, very end? We're going to have a picnic. So again, law of syllogism, it was just his Chromebook. Law of syllogism, we cut out the middleman. I'm going to skip this middle one for now. Let's go down to the bottom one. Don't worry, we'll go back up to the middle one. Let's go to the bottom one. If a number is even, let's call that P. A number is even. Then it may be expressed as a multiple of 2. Let's call that R. Sure. We skipped Q, but we can call it R. Why not? Or purple. Yeah, we can stick with the same color scheme. That works. They're just letters. It doesn't matter. Okay? If a number is not odd, is that something new or something old? Not odd. Do you see not odd anywhere else? No. I know you know that that's the same as even, but on paper it's not. So let's call this something else. Let's call it Q. Then it is even. Is that what colors it is even? What color? Yeah, yellow. That's P. Okay. So what we have here is I'm going to do some reordering. Does anyone see what my middleman will be? P. Your middleman, whatever you're canceling, is always what you have 2 of. So what we have here is Q implies P. That's the second one. And we have P implies R. And I cancel out my P. So what can I conclude here? Q implies what? Q implies R. Notice how Q was not the first thing listed in the sentence. Up here, the first thing listed is the first thing we wrote. They might try to trick you. Q was way over here, okay? So be careful, label your statements. We want if a number is not odd, if Q, then what can we conclude? Go ahead, Reagan. Perfect. Then it may be expressed as a multiple of 2. What's that? Yeah. So again, law of syllogism, we cut out the middle man. You might have to do some reordering to do that.
Is this all we're doing today?
Uh-huh. We have 3 more examples, then we're done. This next one, this is a very mostly true thing. I do play Fortnite sometimes. If Miss Cruz plays Fortnite, crazy. Let's call that P. Miss Cruz playing Fortnite is P.
Stop throwing
P.
stuff at me.
That's why it's yellow.
Whoever it is, knock it off. Then she will eat pizza for dinner. Is pizza new or old? New. Let's call it Q. If she eats pizza for dinner, new or old? Old. That's still orange. Then she will go to the gym in the morning. That's new. Let's call it R. So what we have here is P implies Q and Q implies R. So what do we conclude? What's my middleman?
Q.
Q, my pizza. So, Janaya, what do we conclude? If Miss Cruz plays Fortnite, then she'll go to the gym in the morning. Perfect. That is not a true statement. So if Miss Cruz plays Fortnite tonight, then
Jordan, wake up. We gotta give
she will go to the gym.
Jordan, we gotta give him 2 hours. We gotta wake up.
Okay. Give me a thumbs up. And sorry, this R is not part of that sentence. It was a different example. But give me a thumbs up, sideways, down on syllogism and detachment, on deductive reasoning.
I love
Good. You like syllogism? I like syllogism as well.
love it.
Me too, Jordan. Good morning.
Syllogism is.
Okay. Last thing you'll see is combining, focus, we have 2 more examples, is combining deductive reasoning and inductive reasoning, what we did last week and this week, and determining the difference between the two and which one we're using. So remember, anytime you see observations, that is inductive reasoning. So, anything else, for the most part, is deductive. So it says each time Monica kicks a ball up in the air, it'll return to the ground. So next time, when she kicks it up, it's going to return to the ground. What do we think? Inductive for observations or deductive? Inductive. The question is, what type of reasoning did we do to get to this conclusion that next time when she kicks it up, it'll go back down to the ground? The answer is inductive because we're looking at observations. It says each time. So we've looked at multiple observations and we're trying to find a pattern. And the pattern we found was the ball's going to return back to the ground. So because we have observations and pattern, it is inductive reasoning. Also, I forgot to mention this. It just came out of habit. These 3 dots that I've been using, all that means in math is therefore, or hence, or we can conclude. Okay, it's just thus, just therefore. Those 3 dots in like a little triangle shape, that just means therefore in math. So you'll see that a lot when I kind of do shorthand notation. But this first one's inductive. Then it says all reptiles are cold-blooded. Parrots are not cold-blooded. And Sue's pet parrot is not a reptile. What do we think? Did we use logic and facts to get to the parrot's not a reptile, or did we look at a pattern?
Deductive.
Deductive, because we used logic and animal facts. Exactly, yeah. Well, you're cheating off my worksheet.
See, I know what it is, bro. I was asleep when I was listening.
Mm-hmm. But therefore, it is deductive. So there will be a few on your homework that have you determine inductive or deductive. Questions on reasoning or logic at all? Okay, your homework is 2.2 part 2 on big ideas. A lot of you are missing other homework as well, so make sure to check that missing or overdue column and fill those out as well. And we'll start with vocab stuff Wednesday, yes.